Promising to be great. Yeah, we're going to do our best to make sure that you just give me few minutes. Let me share this. All right. Yeah, today is our official day one class on chemistry. This is our official class. Let me put it day one. Yeah, day one, the first live session that we're having in this media space. Please just pardon me because I need to let me just send a link to my students because most of them are waiting for the live session to commence. Let me send this to them. Okay. Okay. All right. All right. Let me just share quickly to them. So that they can join us in this media space. Okay. So that's the reason why I'm here. They are the reason why I am here. Okay. That is. All right. So let's go straight to the point. Just like I said, today, this is the very first topic we are considering. We are going to be talking about and go through all the necessary questions. Yeah, we're going to be talking about matter, its properties, and the necessary separation techniques that you need to know. This is topic one. Topic one in your topic one. We're on topic one in your JAMB chemistry. JAMB chemistry. Please just pay attention. I will do everything possible tonight to make sure that it's actually a very memorable one. We just have an hour interval to be here. Of course, our topic is just revolving around matter. Matter, because what are you separating or purifying? That is still matter. So matter and let me put it and its properties. Matter and its properties. Though some book, when we start going through questions, you will see it as separation of mixture and purification of chemical substances. Please, if you are here with me tonight, just do well to keep sending reaction to the video, and you can as well help me to share it to others so that they can come up. Now, there's let's just go straight. I mentioned matter. You already know. If I ask you what is matter, matter is anything that has mass and occupies space. Are you seeing it now? Matter is anything that have mass and occupies space. Remember, another name for matter is substance. Substance. That is another name for matter. So we say matter is anything that have mass and occupies space. Now, in this, matter can be splitted into what? Two, or substance can be splitted into two. Sorry, I don't really want to rush it. So substance can be splitted into two. Today is teaching. We're also going to be engaging in questions. So just prepare your mind and jot down where necessary. Don't just come to listen. Okay, now look at this. Matter, we have what we call pure matter or pure substance, and what? Impure substance. Remember, I say it's either we say matter or substance. Now, under this pure, we talk about your what? Element. And we talk about your mixture. I will be mentioning so many things. Reading your book alone will not help you to get those things. And under this impure, we can split in. Okay, let me not go there. Under impure, it gives us what we call mixture. Mixture. Just pay attention, you will get it. Impure give us what we call mixture. Then mixture can be splitted into homogeneous, homogeneous mixture, and also what we call heterogeneous mixture. This is homogeneous mixture. Eh? And this one is what? Heterogeneous mixture. If you pay attention, I promise you that everything that you need to know. No, just like when we say pure matter, is those ones that have definite composition and of course distinct properties. We are going to talk about that anyway. Why, of course, when we talk about impure, which is your mixture, you already know how it is being gotten. Are you seeing it now? Don't forget, this is just a species that have one distinct kind of an atom, element. You know the definition of an element. So we're coming to that. Then combination. Oh, imagine this. Sorry, this is compound. Compound. Pure matter is splitted into elements and compound. Of course, you know, two or more elements chemically combine to give you compounds. Take note. They're chemically combined to give this, while they're physically combined to give mixture. Just pay attention, just like when they ask you question about the building block of matter. The building block of matter, you know that they're talking about atom. What exactly is the answer to that question? We're going to talk about that as we proceed. So don't forget, pure substance show the following properties which can be used as test for purity. When we talk about pure substance, pure substance or pure matter, pure substance, I'm talking about this now. Pure substance, just briefly, pure substance, listen to me, everybody. I say pure substance shows the what? Following properties which can be used as test for purity, and of course that is what distinguishes it from impure substance. What are those properties? As a pure substance, you must have, that is why I say you should have your pen and paper. You must have a precise melting point. Yeah, precise melting point. That is one of the characteristics of a pure substance. Which other one do we have here? A pure substance must have a precise boiling point. Boiling point. And it must also have a definite density. Definite density. Yeah. All these are the basic things that you need to note about pure substance. Don't forget, I splitted matter. We say matter is anything that has mass and occupies space. And if we go in detailed definition of what mass is, you know, mass is what? Simply the quantity of matter that the body contains. Are you seeing? So that is just it. So matter is anything that have mass and occupies space. Then matter is split into pure matter or pure substance and impure substance. Please, if you are here with me, do well to keep sending reaction to the video. Do well to keep sending reaction. Yes, just stay glued and make sure that you are getting and penning something down. If you are not seeing it, you can as well drop your comments or just a message below so that we know what exactly is the issue with your this thing. Okay, now we all right. So we go straight to what element. You are still on this. You know, element are substance. Please, I hope you are noting down. I'm done with, I'll say one or two things on what pure substance is. For you to be a pure substance, you must have a precise, simply called definite melting point. Sharp melting point, precise. That's what we call precision and accuracy. So a pure substance must have a precise melting point, a precise boiling point, and a definite density. It is not too hard to know this. We can still talk about refractive index as regard this thing. So we are moving forward. Let's go to elements. Quickly, let's talk about elements. Do well to keep sending reaction to the video. Elements. What can we say about elements? Yeah? Because element and compound are what make up the pure substance. Don't forget, elements or two or more elements chemically combine to give compound. So note that elements are substance. Elements are substance. This is simply what? Substance which cannot be broken down into other simpler units. by an ordinary chemical means or process. You know this now. An element is a substance, or elements are substance which cannot be broken into other simpler units by an ordinary chemical process. That is what an element is. Yes, that is what an element. All element can be grouped in the form of maybe periodic table, periodic charts. Of course, there are six type of elements. When we go to periodic table, we'll talk about that. The reactive metal, transition metal, lanthanide and actinide. Then we have pure metals, non-metals, and noble gases. So that is it. So let's go straight to the compound. I want to just explain this concept that revolve around this. We have a lot to talk about, and we have questions. So that when I put question on the screen, we should be able to go squarely precept upon precept and get all the would be answer as regard that. This is topic 1. I started everything now from the scratch. That is why you see this is day 1. Pay attention and make sure whatever you not get, do well to drop your ask me your questions. I don't know how I could possibly bring you up to speak or use audio and all that, but do well to follow through. Now let's talk about compounds. Compounds, compound. When we mention compound, what do you mean by that? Compounds or compounds simply means substance which contain, I already said this, which contain two or more elements chemically combined together. That means two or more elements chemically combined to give compound, and two or more elements physically combined to give mixture. We're going to talk about that. Anyway, compound are substance which contain two or more elements chemically combined together. Sorry. Okay. Sorry, I hit my distance. Now, chemically combined together, that is what compound is. Compound form as a result of chemical change. My people, do you still remember what we mean by physical change, physical change and chemical change? Do you still remember? I should mind my business. Physical change and chemical change. Do you still remember what these two things stand for? One of them is a change that leads to the formation of new substances, and it is not easily reversible. Not that it cannot be reversed, it is not easily reversible. Why one is the one that does not lead to the formation of new substances, and two, it is easily reversible. Are you seeing it now? So, of course, I say physical change. I want you to understand this. Physical change are simply change that does not lead to the formation of new substances. This one does not. Physical change does not lead to formation of new substances, and it is easily reversible. That means it is a reversible reaction. That is why for physical change now, sorry, I mentioned what compound is. I told you, since compound, two or more elements chemically combine to give that. I say a compound is formed as a result of chemical change and new substances with entirely different properties. Oh God, please, someone should know. Before I come back to this, pardon me, because the reason why we are here is for you to get the best. What do I say about compound? Let's retreat on that. What do I say about compound? What do I say about compound? Yes. Okay, now let's go through it again. I say compound, it simply means compound are substances which contain two or more elements. Compound are substances. I'm talking about this. Compound are substances which contain two or more elements. Yes. Chemically combined together. This one, when we talk about compound, they combine how? Chemically. Chemically. Are you seeing it? Chemically combined together. They combine chemically. Now we are going somewhere. This is just an hour interval and we are done. But if you pay attention, I promise you, you can still rewatch this video. Yeah, you can still go through all this. I think the audio is very clear, and I'm also making illustration that will help you get better with this. Now, for compound, we say they are chemically combined. We are still going to learn revision with time on this, and it will be on a different frequency. That is why if you are here with me, please keep sending reaction to the video and do well to share it. Now, of course, I told you that a compound is formed as a result of what? Chemical change and new substances with entirely different properties from those of its component element. That means the constituent element that make up. Oh, this is a question. No, this is a question. I repeat. Let me see. Hold on, so that because as you are saying it, you know whether if the note or if the point I'm giving you this night will help you answer question or not. Yes. Please look at this, even though I've already ticked the answer. Look at this question. Look at this question. If you can see my screen, please send reaction. Send reaction. If you can see the question paper I just displayed now, send reaction. Send reaction. Let me know. But there is no, just send reaction. Nobody. So okay, that is good. That is good. Now let's look at the question I'm talking about. Are you seeing the question? Question. Sorry, let me use. I have to use pencil. I don't like using biro on a paper because we still use it for others. So okay. Yes. Now, sorry. Now look at this. Look at the question. A difference between a mixture and a compound is that. Think this is the best moment of this. Now look at this. I don't want us to. The time will come, one after the other will answer it, but now it's teaching time. Pay attention. A difference between a mixture and a compound is that. I mentioned something before that. As a constituent element that make up a compound do not retain their individual identity. That means they change. I don't know whether it sounds like what you understand though, but look at this. A mixture have chemical formula while compound do not. That is not true. It was the reverse. Mixture does not have chemical formula, whereas compound do have chemical formula. This say the properties of a compound of a compound are those of its individual constituents, while those of a mixture differ from its constituent. That is the reverse. That is the reverse. That is the reverse. Are you seeing it now? Then C say a mixture is homogeneous, while a compound. Let me tell you why this C is not correct. Both mixture and compound are homogeneous. Both can be homogeneous. Homogeneous mixture is known as solution. Are you seeing it? Homogeneous mixture is known as solution. That is why C is not correct. But when we go to D, component of a mixture are physically bound. Normally, you know, two or more elements physically combined to give mixture, while those of compound are chemically bound. That is the most excellent difference between compound and mixture. We're coming to this, like I said, this is just, we have a lot. When we go through past question, you will know. And we have to analyze it in our best way. So please, I want you to just keep paying attention. Let me drop this aside. Yes. So let's go again. Let's go again. Just pay attention, and I promise you every necessary thing that you need to know, we do our best to make sure that it get to you. I say compound formed as a result of this compound. You form as a result of what? Chemical change. Chemical change and new substances with entirely different properties from those of what is component element or constituent element. When we talk about water, example of compound now, we have H2O, water. The properties of hydrogen and oxygen are different, but as they form this, the properties of water is entirely different from that of what? Hydrogen and oxygen that make up water. That is what we are saying here. The same thing when we go to our table salt, sodium chloride. Properties of sodium and sodium chloride now as it combined is different from that of sodium and different from that of what? Chlorine. That is what we are talking about. Eh? And you must know what is this. If they ask you air, is air a mixture or compound? Is air, I want you to tell me something based on what you have, your knowledge so far. Is air, is it a mixture? Is air a mixture or compound? Are we taking this as a mixture eh, or compound? Or compound? Let me just short form it. Air. Which of them is air a mixture or compound? What do you have to say about that? We're taking time. All right. So air is actually a mixture, but no issue. Let's just go to the next line of action. We're done with you can see my table, the chart. I told you pure matter or pure substance are your what? Element and compound. Now we're going to impure. Air is a mixture. Thank you very much. Now impure substance, and your impure substance is simply the mixture. The mixture is now splitted into homogeneous, meaning the how will I put it? The constituents are of uniform formation, homogeneous, same formation or same constituent throughout. Heterogeneous, different constituent throughout. Okay, or different constituent. Now, let's talk about mixture. You already know. I told you that mixture, for mixture now, how will I put it? Yeah, for mixture. Let's talk about mixture. I said two or more elements physically combine to give you two or more elements physically combine to give you mixture. You should know that. They ask you maybe probably you should know that the constituent of mixture can be elements or compound or even both. Constituent of mixture retain their individual properties. They still contain that property they initially have is still in them. That is constituent because they are just combined physically. Constituent of mixture still retain their individual properties. Unlike compound, I've shown you a question on this. These things are important. These things are important. Yeah, constituent of mixture still what? Retain their individual properties, unlike that of what? Compound. And I hope you are paying attention, you are taking down some possible notes, please, because this is really necessary. It's important. And I wouldn't like you to waste your sleepless night, waste your data at the same time, and you are not benefiting anything. Well, gradually, because by 11 we are done with this. By 11, just an hour interval, and I want to see what we can get. And there is going to be an assessment at the end of all this one. There will always be an assessment, both physical and online assessment. If actually we mean business this season, then forget it. We are going to set a new record for JAMB, and that's it to set. Mixture is just physical combination of two or more elements. Physical combination. So that is it. So constituent of a mixture retain their individual identities because their physical and chemical properties are not changed by simple mixing. Example, soil, air, Coca-Cola, and seawater. All these are mixtures. All these are mixtures. I've seen it. Oh God. Where is that question? Where can I get that question? They ask which of the following. Okay, just bear, don't worry. I'm going to open to past question. They ask seawater was the answer there. Seawater. That's why you shouldn't, when you are here to just open your mind. Let me quickly go through now chemical change. I just want to, you already know one or two things about it. Chemical change. Chemical change. Chemical and physical change. Let me just put it this way. Chemical and physical change. Please take notes. I just want to do something. Let it at least jot down what you can jot there. Chemical and physical change. Let's start with chemical change. Chemical change is actually any change. This one, it is any change that result in the formation of what? New chemical substances. Any change that result in the formation of new chemical substances. When you burn firewood and it turn to ash, you cannot reverse it. Or simply put, it is not easily reversible because in science, almost everything seems to be possible. Yes. Though I would have tell you a story, is not permit me to digress a bit. Scientists since time immemorial have been working assiduously on how to separate the North Pole of a magnet from the South Pole, and they have not achieved that end. That's why God is the greatest of all scientists. Are you seeing something? They have been working. Scientists, are you seeing it? To separate North Pole of a magnet from South Pole. Magnet is naturally being made. And that is why we say there's a place in China known as magnesia where you can find what we call rose stone. But let's talk about that on physics. And the same way we started chemistry from the very scratch is how we are going to also start physics from the very scratch. Don't forget, today we have trashed down matter, taste for purity of substances, pure substances demystify, and under pure substances we have talked about element and compound that make it up, and under impure substance or impure matter we have mixture, we have discussed mixture, or we have talked about mixture. Yeah, and I told you homogeneous mixture have same composition throughout, while heterogeneous have different composition. So from there, we now talk about changes, that are physical and chemical changes. And on chemical changes, I told you that it is any change that results in the formation of a new chemical substances. Please do well to keep sending reaction to the video. Yeah, it means a lot. Others can easily discover that we are here and they will also take part of what is going on. You were to keep sending reaction. Yeah, thank you very much for those of you that are actively participating. Just like I said, that chemical change is any change that result in the formation of a new chemical substances. Now, of course, there are different examples. There are different examples when we talk about chemical change. Though I want you to note just this: rusting of iron, burning of gasoline, egg cooking. When you cook egg, that fluid protein molecule uncoiled and cross-linked to form a network. You cannot return it back. Bread rising of bread. Are you seeing it now? That yeast convert carbohydrate into carbon dioxide gas that causes this thing to do or to rise. So we talk about milk souring, sour milk, sour tasting of that is lactic acid. That is when milk sour can produce lactic acid. Yes. Then and other examples. All these are basic things that you see. Burning, anything burning, burning is chemical change. Yes, you should take note. Then we talk about physical change. What do you remember? This one is not reversible. Simply put, it is not easily reversible. That is for chemical change. But when we talk about physical change, what do you need to know? Physical change actually is there to rearrange molecule but does not affect their internal structure. It is actually there. Like now, you have an ice block. Are you seeing? Ice block, all of a sudden, it melts, forming pure liquid. But when you take it to some this thing like a freezer, it can still get it back to the ice form and all that. Please, let me say this. Knowledge, no knowledge is no, not even no knowledge. It's still safe. When they ask you formula for ice, human, please pay attention. Oh, there is nothing like H2O in solid state. There is nothing like water in solid state. The formula for ice remain CO2 in solid state. That is formula for ice. I will keep mentioning things. You can see how our paper is looking, but God knows that we have discussed a lot. Yeah, I would have shown you. Now, when we are making this review, permit me to digress a bit. Let me show you small something. See the way I couldn't show you on my library, but you can see that all these are different reviews I'm doing before coming to. You can see the way I stack it up. I know what to pick, I know what I've solved on, and I know what to give you at every point in time. Please do well to stay connected. I'm telling you, you see, this season will really mean well for you guys, and your aim and objective is going to materialize just for you to use your time, utilize your time, because you do not have it all. Now, physical change is a change that does not lead to the formation of new substances. Are we good? Yeah, it does not lead to the formation of new substances. What again do you need to know? There, it is easily reversible. It is easily reversible. That is it. My, which example should I just give you? Let me use a change in state of matter. You see all this solid. You see liquid, and you see gas. Yeah. Now, and you see here there's a process whereby solid change to liquid. We call it melting. I mean solid melt. But when it is liquid that change back to this, we call it freezing. All these things are physical change. Now, if it is a liquid that changes to gas, liquid to gas, we call it evaporation. Evaporation. Or boiling. There is a difference between evaporation and boiling. I mention, I have to give you detailed explanation. Evaporation is actually a surface phenomenon, and not just that. What again can we say about it? It takes place at all temperature. But when we talk about boiling, boiling takes place at a definite temperature, and it is a bulk phenomenon. If it is a gas that change back to liquid, we say it is condensation. Condense, you are condensing gas, squeezing it, condensation. But when solid move directly to the gaseous state, without passing through the liquid, we call it sublimation. Sublimation. That is the name. They are all JAMB question. Don't joke with this. But if it is noun gas that move directly to solid, look at this. Gas move directly to solid without passing through the liquid state. We call it, at times they say desublimation, but the real name is deposition. Deposition. Please take note. Deposition, or they can say desublimation, just the reverse. Desublimation. So whichever one, but just know the process. That is it. Know the process. Okay, we are done with this. All these are physics. I just mentioned this. You can read up others. We are in a media space. I beg. You can read up others. I just mentioned this. I just mentioned this one. You can read up others. We have a lot. If I'm to, I don't even know what to say, because we're going through past question in no time soon. This is already 10:33, and I'm highly careful about time. Highly careful about time. So don't forget, at times I will ask you, dash is the temperature at which the saturated vapor pressure of the liquid equal to atmospheric pressure. What they just define for you is boiling point. Boiling point is the temperature at which the SVP of the liquid, which is saturated vapor pressure, equal to pressure of 1 atmosphere. Now, you should just know all these basic things, and I promise you, you have done noble to yourself. You have done noble. What I will like you to try and study something like boiling curve, cooling curve, melting, all those things. Just know one or two things about it, because time is not really on our side. I want to talk about separately process. Let's see, but before that, so that it will not look as if we are rushing, I want you to understand. I say matter is anything that have mass and occupy space. Then, of course, weight is the force on a body due to gravity. That is what we call weight. Eh? So weight and mass are going hand in hand, but just the influence of, simply put, the influence of gravity on mass is called weight. If I ask you now as a science student to differentiate the two, to differentiate. Imagine now that the equation I give you will have weight. Yeah? Then we are trying to differentiate between this and the what? Mass. You should be able to tell me that what is the SI unit? This one is measured in Newton. Sorry, I have to just put it down, but go through my audio or my voice. I said the SI unit of weight is Newton. The SI unit of mass should be what? We are talking about the SI unit. SI. Why this one should be kilogram. Are you seeing it? Then you also talk about what are them? What do we use to measure them? You can see weight can be measured or estimated using spring balance. Spring balance. Yeah. And that spring balance operates via the principle of Hooke's law, provided that the elastic limit is not exceeded by Hooke's law. Now, force is proportional to the extension produced. Now, for this, what do we use? We use a beam balance. Yes, beam balance. Beam balance. Beam balance, which can be chemical balance or your physical balance. And through what principle do they achieve that? They achieve it through the principle of moment. Yeah? You take moment about a point. Then you can see use other things to differentiate them. There's a lot, but basically these are the necessary things. You can also tell them weight varies from place to place, while mass is constant. Weight varies. Yeah? Mass is what? Fixed or constant. All this thing. Because your mass here or anywhere on the planet Earth remains same, but your weight differs. Your weight differs. Don't forget this. So just because I'm the one saying it, don't. Make sure that you are paying attention. I'm also watching time. The same way you are watching it, I'm doing everything possible to make sure at the end of each encounter, you have something good to show for it. You already know that the state of matter, when we talk about matter, solid, liquid, and gas, I don't need to mention that. A solid have definite shape and volume. That is one thing. This is a point. When we talk about state of matter, solid, liquid, and gas, what do you need to note about solid? Solid has definite shape and volume. A liquid have definite volume, but no definite shape. Are we together? Now, a gas has neither a definite volume nor shape. I've said something about physical change. I'm trying to just summarize what we have discussed on. So physical change is one which is easily reversible and in which no substances or no new substances are formed. Take note. I give example changes in the state of matter I have mentioned in the previous slide. So you should take note of that. When we are here, we are going to chook mouth into plenty matters. And that is why do everything possible to make sure that you are keeping to the pace of our activities. And for those of you, maybe you are not in our WhatsApp group, you can do it to send me message when we are done on 09038377238 so that you can easily be notified whenever we are in that media space. Do it to do so. And what again? We have mentioned so many things. We also talk about chemical change, which is one that is not easily reversible, and of course it leads to the formation of new substance. I've given so many or some examples of that. Okay, I told you an element is a substance which cannot be split into simpler units by an ordinary chemical process or means. Don't forget the three most abundant element on earth crust. Three most abundant element is now, I have to sound a little bit verbose. Now, three most abundant element on earth crust are oxygen. Oxygen is, I'm talking about earth crust. Three most abundant element on this earth crust. Oxygen is 50%. We have silicon. Silicon is 26%. And then aluminium is like 7%. Yeah, you have seen that chart, except it have changes. So of course the most abundant element in the atmosphere, this one is in earth crust. Note, The most abundant element. Let me note it down so that I will ask you. Just don't joke with this. The most abundant element, the most abundant element. Are we together? The most abundant element. I repeat, the most abundant element in the atmosphere. Let me just put it down. Atmosphere. In the atmosphere is nitrogen. I hope you are seeing my handwriting. That is the most abundant element in the atmosphere. So take notes. It is nitrogen. Compound is a substance which contains two or more elements chemically combined. I'm sounding it this way so that those of you that are just joining and that not get, so I'm retreating on what we have discussed thus far, and you should take note of these things. I've shown you past question is the easiest thing to answer when you have access to this. The easiest when you have access to all the, look at this now, look at this, look at what we did. We started from the very scratch, not as if we are rushing anything. Past question become nothing, like you chop it like your favorite meal. I use it. So that is why when you are here, please do well to keep sending reaction to show that it's not just me, we are together in this media space. Okay, that aside, I've mentioned few things. I've told you the most abundant elements. So don't forget what I told you about mixture. A mixture contains two or more elements which can easily be separated by physical methods. Since they are combined by such method, a mixture is splitted into homogeneous and heterogeneous mixture. Homogeneous in the sense that it has same composition throughout, heterogeneous in the sense that it have different composition and all that. So we are going to dribble on separation techniques in our next session, next class, because I want to just bring in some questions. Let me see if we can actually get to some basic question revolving around what we have done thus far. Please permit me this time around. Let's go through question. Let's go through question. I want to keep it in a way that you see it clearly. Are you seeing this question? Question number 1. Are you seeing question? The question said, question number 1, in an experiment, which of the following observation would suggest that a solid sample is a mixture? The solid can be grounded to a fine powder. Iyawo, if not people that are making all this useless exclamation. B, density of the solid is 2.25. This look like, was it density of whether graphite or diamond? Okay, let me not just go there. Is this density of the substance? Remember they said in an experiment which will suggest that a solid sample is a mixture. So anything that have definite density show that you are a pure substance. So mixture is an impure. Take note. So B is not correct. Solid can, anything can, both pure and impure can be grounded to a powder. So A is not correct. B is for, if you say they are talking about pure, so B would have been correct for one of the tests for purity. Then C, solid begin to melt at 573 Kelvin. Are you seeing language? But it is not completely melted until 648 Kelvin. Are you seeing this? Then D, solid melt at 300. This D is a definite temperature. But C is the correct answer because it shows wide range of temperature. Me, I like being straight. When I'm here with you, you need to Probably pay attention to some basic things. Pay attention. You can see the respective JAMB years. We just have 5 more minutes to go through one or two things. Yeah, thank God for question number 2, 1980. I even mentioned something. It was the question I was referring to. 1987, question number 2. JAM 1987, number 2. Which of the following is a mixture? Dated level, I don't know. Which is common. Iron firing. So what do you suggest? What do you suggest? Which of them? What do you suggest? Which of them is a mixture? Please, someone should just say something. The answer is what? Seawater. Yeah, seawater, their composition is not uniform. Seawater. Seawater. Please take, take note. It is seawater. Seawater. That is good. 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 You are doing well. You are doing well, Kelvin. So it is seawater. So which of the let's take question 3. They say which of the following, we still have 4 more minutes or less than 4 minutes. We are done. So question, yes, you guys are doing well, is B, seawater. Then question 3, which of the following are mixture? Petroleum. Remember, petroleum, I, petroleum, B, rubber lattice. Now multi-choice question. Remember, they say which of the following are mixture? They mention petroleum, mention rubber lattice. Good. Are you seeing? I say question Boku. Now you go calm, you go calm. Everywhere go first, they alright. No, nothing like everywhere go first, bro. When you get it right. So now I vulcanizer solution. Okay. So I want I know, sorry, let me zoom my this thing very well. I hope you are seeing it because I want you to see it very well. Permit me to just go through a few questions, then we see how to call it a day. So we have petroleum, we have rubber lattice, we have vulcanizer solution, we have carbon 2 sulfate. What do you suggest is the answer? A say I, and I. So, of course, vulcanizer solution is actually a mixture. Petroleum is a mixture which will separate the component through what we call fractional distillation that revolve around close range of boiling point. Then, of course, I don't know, carbon 2 sulfide is the only chemical compound in this. So just know that. Yeah, carbon 2 sulfide. So A is correct. Yes, A is correct. Actually, A is correct. A is correct. So question number 4 now. Question number 4. Yeah, question number 4. Okay, that is good. Question number 4. Which of the following is not a homogeneous mixture? Filtered seawater. In fact, someone should just drop the answer in less than no time. Kelvin Chukemeka, I'm waiting for you. Or Chukemeka Esther Cheta, please, I'm waiting. What is the answer to number 4? Correct. That is good. That is good. That is good. That is good. Now, you see, which of the following is not a homogeneous mixture? I told you we have two types of mixture. Filtered seawater have same composition throughout. Soft drink. Have you ever buy Fanta and you are chewing granite inside? You know, say your village people are mean you and they are there to to finally take what belongs to them. That is just it. So it's not possible. It's not possible. You cannot all of a sudden, except they package it at the back of your house. Now, or C say fraud water. Yeah, this a writing ink. That is why ink contain one color throughout. Not today it is blue, tomorrow it is red, next tomorrow is yellow. Now, fraud water contains so many elements in different composition. It contains both mommy water, papi water, brother water, everything in different composition. Are you seeing it now? So in different composition. That is Don't mind me, just know that the answer is fraud water. Let's not go too far about that. Oh God, what of number 5? Which of the following substance is a mixture? Sulfur powder, bronze, distilled water, ethanol, and you're waiting. That kind of this thing. Have you forgotten that bronze is an alloy of copper and tin? Copper and tin give you bronze, while brass is copper and zinc. So they are mixture. Alloy is just an example of mixture. Correct. You guys are doing well, and I love that. That is good. That is good. That is good. You have just 10 more minutes. We are stopping exactly at 1 hour interval. That is how our session will be. Any day we are meeting here, while other platform will just be revolving around maybe 30 minutes. Okay, but I hope we are not wasting our time. Please, if I'm not wasting your time here, can you send reaction to the video or to the live session, please? Can you react if I'm not wasting your time? Or you can keep quiet if actually you are wasting your time. That means I'm wasting your time. Okay, better. I'll just truncate and take down the video. It's okay. You guys are doing well. I really do appreciate your passion. Is driving me crazy, like crazy. Okay, so let's go to the next question in our agenda. Let's go to the next question. What do we have up next? A pure, oh God, I said this question go sweet you die when you understand. Don't look at it now. Look at, as you're answering question, take a look. Even as much as we are going through that, I could remember for a pure substance I mentioned precise melting point, precise boiling point, and a definite density. That is what we call percentage test for purity. Good, you guys are doing well. Yeah, the person already answered. Oh, wait. Do you answer Chukuma Esther Cheta? Well, you tried, but check your answer again. Okay. All right. Let's see. Let's do. Wait. I think. Let me check where. Okay. One person have gotten it. A pure solid melts, usually melt dash A over a wide range of temperature. God forbid, that one is a mixture, impure, which is usually mixture. B over a narrow range is just like talking about sharp melting point. Sharp melting point. That is it. Narrow. It just within small gap, it already melts. That is characteristic of a pure substance. Are you seeing it? Characteristic of a pure substance. That is it. Please make sure that you're understanding. Whenever we are here, we have to display, we have to make you understand. You see, this season, for those of you that will be sitting for this JAMB exam, it is higher, or you are coming as one of the top scholar. That is your top, yeah, you are going to be announced and all that. So you just have to make up your mind and prepare. Get angry for once. Get angry and do thorough preparation for this tournament, because it's going to be a win-win situation. And I wish you guys the best. So just like you see, it remains 7 minutes before a clock, an hour interval, or 6 minutes. Let me know we are 6 minutes. So now look at this. The answer to that number 6 is actually a B. Now let's go to graph. May you no look like say we're avoiding any question. Not possible. Avoid waiting. Now we there here, so you just have to know your onions, pay attention where necessary. Now I want you to carefully study this graph. Carefully. We are stopping any moment. I don't have issue. You guys have tried. Look at it now. Since most of you stay consistently, it is not easy. Use the graph below to answer question 8 and 9. Egbe. That is why question 8 say PQ indicates. I think that is okay. Is it question 8 or I'm seeing question 7? Okay, maybe it will. Okay, let's just go, because they mentioned 8 and 9, but we're having more than that. No, it's they just question 7 is supposed to be 8. The session PQ. Wait, this is our PQ. The session PQ indicate that X is dash. X is dash. Remember, maybe this is a melting or whatever, but look at the temperature range from this to this. X is dash. That is, I don't even know how to explain. Okay. Wait. Let's take a look at this. The session QP or PQ indicates freezing point. Yes, that is it's actually freezing. As we are going to study, I'll bring all this graph up again. Oh, someone said we are not seeing it well. Sorry. Can you see it now? All right, please just check the graph. This is O. Where I'm pointing is O. This is P. This is Q. This is R. Okay, thank you. Someone already. That is good. You guys are doing well. Yeah, that is good. That is good. That is good. That is good. Yeah, the session QOP is actually indicating that this substance is a pure compound. Then how do you know it's a pure compound? How do you know? A point that is it's talking about the freezing point when the temperature remains constant. Like freezing point. So temperature is same too. Look at this. That is why you go on a horizontal. Not that you move from here, changes to this, changes to, so it remain constant. And that definite temperature is indicative of what? Pure substance. Precise temperature. Thank you. That is good. That is good. That is good. So this is, because the more we study more charts like this, the more I'm still going to bring more than this. Just hold me by maybe during our revision session. So now let's quickly go to the next question. Question number, this one now. The session OP. OP. What does OP stand for? OP. OP is just, OP is actually talk about liquid state, solid/liquid state, solid state, gaseous state. I'm going to really do something about this maybe in our subsequent, whether physical class or not. I'll see what to do. So that session implies that X is in the liquid state, liquid. Because this is like a cooling curve. You see it? Cooling curve. So it's liquid state. It's liquid state. One, if it is boiling curve, that one move this way, and move this way. Just the reversal of this. So don't worry. I'm going to just see how I will add more to this. Then before we God, please just take a look. Like, I don't like stopping things halfway. Question number 9. What a sweet question. What a sweet question. What a sweet question. Are you seeing it? I want you to just see it where maybe we are stopping. They just 58 minutes. I want to actually keep to this time. Okay, let's do up to 10 questions. Yes. Okay, question number 9. What do you suggest? Which of the following compound is composed of aluminum, silicon, oxygen, and hydrogen? Is it Epsom salt, limestone, clay, or urea? It is actually a typical example of clay. That is kaolin. It is kaolin, which is it contains aluminum, silicon dioxide, and water. So that is it. Kaolin is kaolin. So it's actually clay. C is the answer to that question number 9. Last 10 questions. This is pure solvent are obtained by dash. How do we obtain pure solvent? I had not discussed on separatory this thing, but don't worry, I'm going to do that. Nowhere we stop. So let's just answer that question number 10. How do we obtain that? It is usually by distillation. Take note, pure solvent are obtained by distillation. Yes, you can distill, then you have the pure solvent. I think with this, we call it a day. Thank you very much. I do really appreciate you guys are doing well. I promise you we are going to keep to the momentum of this session. Just do well to, keep referring others, and when we are here, you guys are doing well. Keep dropping more reactions to the videos. Of course, this is a recorded session. For those of you that still want to have access, let me use it to cover this as part of the question. Remember where we stop. Let me mark it. We stop at this question 10. We stop at question 10. So when next we are on this media space, we will do more than this and add up to this, and then gradually we get to where we ought to be. I do really appreciate. Thank you very much. And sorry for adding extra 1 minute and few seconds. Have a wonderful night. See you guys in our next session. Tomorrow we'll have a session on, of course, what we are discussing on TikTok is usually 30 minutes. So if you can meet up, you can still join us 6:30 to 7. We are done. And I will keep to time. But know that whenever we are coming, we are trying to just achieve something. So that is just it. See you guys in our next class. Thank you very much, Kelvin, Chukemeka. I really do appreciate. You are doing well. Yeah, and others. Chukuma Esther Cheta, God bless you. And others that I'm not really seeing their name here. God bless you guys. You have been awesome at Fitness with Abraham. Thank you very much. God bless you. See you guys in our next class.